Okay, the next one here, it says, consider the long-run behavior of x squared plus x minus 12 divided by x plus 2. If the numerator is of greater degree than the denominator, and how you can tell the degree is it's the biggest power of x. The biggest power of x in the numerator is 2, the biggest power of x in the denominator is 1. If that's true, that the numerator is greater than the denominator, you're going to have to do long division. So we would have x squared plus x minus 12 divided by x plus 2. Then you'd ask yourself, what do you have to multiply x by to get x squared? So it'd have to be x. So x times x squared. Let me make sure we can still see this because I kind of moved it. Yeah, we're fine. And x times 2 is 2x. Then we subtract x squared minus x squared 0. X minus 2x is negative x minus 12. What am I going to have to multiply x by to get it to be negative x? Well, negative 1. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. And then I subtract x plus x 0, negative 12 plus 2, negative 10. As soon as this degree is less than this one, then you can stop. So I'm going to go, say it's minus 10 over x plus 2. All right? So for looks like, because they're going to ask you then, what does it look like? Well, it's going to look like y equal to x minus 1 minus 10 over x. All right, remember we take a ratio of leading terms? So there it is. It has an oblique asymptote. It's called oblique if it's not just horizontal. The reason I know it's not horizontal is because it's y equal to x minus 1. It has an oblique asymptote at y equal to x minus 1. And I know at that it behaves like negative 10 over x, which looks like this. Same thing as negative 1 over x, okay? So if you were to sketch the picture of this, you would say it crosses the x-axis at negative 1. That's the y-intercept. It's got a slope of 1. Remember, slope is rise over run, so you'd rise 1, run 1. I know you can do this because you had to pass Algebra 1 to be in pre-calculus. But it behaves like negative 10 over x. So on the right side it approaches it from below, and on the left side it approaches it from above. If we wrote behavior statements, we would say, as x approaches infinity, f of x approaches the asymptote from below. And the other side is as x approaches negative infinity, we would say f of x approaches, it always approaches the asymptote, and it would approach it from above, because it behaves like this, okay? All right, and we would say it's an oblique asymptote. It's not horizontal, it's oblique. It's not parabolic. All right, everybody happy with this? Good.